Okay, so today we're going to go over necrosis. And this is just the basics, but I figured by being a veterinary student myself, like it'd be easier for a student to describe it to a student in hopefully a more understandable way than a pathologist trying to explain it. Because sometimes you look at that as a student and think, what are they on about? So hopefully this helps. So we're going to cover briefly oncotic necrosis, which is just general necrosis, coagulative necrosis, caseous necrosis, liquefactive necrosis, and gangrene. Right, so necrosis in general. So it causes inflammation, unlike apoptosis. So apoptosis is controlled cell death. So it's done all nice and neatly and stored away inside macrophages. However, with necrosis, the cell is just lysed. So all of that nuclear debris, cellular debris, it all goes everywhere and causes an inflammatory response. And as mentioned, there are different types like coagulative, caseous, liquefactive, and gangrenous. So the histologic morphology of necrosis. So the nucleus condenses and darkens. So we got our pycnosis. Then the nucleus fragments. So it splits off into loads of little bits. And that is karyorrhexis. And then in karyolysis, which is the final step, the nucleus fades and disappears. So you get this really faint outline. And you can make any sort of acronym you want. I mean, I just went with parsnips kill kids just because, I don't know, I thought it was funny. But yeah, so to go over that again, nucleus condenses and darkens, nucleus fragments, and then the nucleus fades and disappears. So coagulative necrosis is intensely eosinophilic, so it's very pink histologically. The outlines of the cell remain, but the nucleus is gone. So you still got the tissue architecture under the microscope, so you can still see where the cells would have been, but there's no nucleus there. And an infarction, so when the blood supply is disrupted, is a common cause of that type of necrosis. Right, caseous necrosis. So it's cheese-like, hence caseous, because I think that's Greek for cheese. But anyway, that doesn't matter, I can't speak Greek. So yeah, it's cheese-like. Tissue and cell architecture is absent, and broken leukocytes mean that basophilic debris is commonly seen. So you see all sorts of little blue specks, and these were neutrophils that once were, that are now broken down. And that's commonly seen with, for example, Mycobacterium bovis or bovine TB, where you get the nodules or the granulomatous inflammation. Those leukocytes will be present there. And when they're breaking down, that's an example of caseous necrosis. Liquefactive necrosis. So tissue and cell architecture is absent. Tissue is fluid, hence liquefactive. And common types of necrosis in the nervous system components, for example, brain, spinal cord, etc. And in the brain and spinal cord, it's known as a malacia. And then finally, gangrenous necrosis. So there's three types. We've got dry gangrene, wet gangrene, and gas gangrene. So dry gangrene is quite leathery-like, and it's a type of coagulative necrosis. So it has the same pathway almost. Well, it does, yeah. So there's an infarction, and because of the disrupted blood supply, it causes cell injury, and then type of coagulative necrosis. And now we got wet necrosis, which looks histologically like liquefactive necrosis. However, there's bacteria present, and because it involves bacteria, you would see an innate immune response. So there will be leukocytes present, a lot more so than in liquefactive necrosis. And that will be the same with gas necrosis. However, with gas necrosis, the reason it's gas necrosis is because the bacteria produces gas. So if the bacteria doesn't produce gas, it would just be a wet necrosis, a wet gangrene. And here are just the resources